This video delves a little deeper into working with the inverse square law and just manipulating this gravity equation in general. So just as a reminder, this is the equation for the gravitational force between two objects. Now let's address this question. The force between two objects is 50 newtons. What will the force be if one object doubles in mass? We know that our equation will look like something like this in the beginning. So we know that the force is 50 newtons, but we don't really know these other values yet. So if we want to double one of the masses, we will put a 2 next to one of the masses on the right-hand side of the equation. And in order to keep both sides of the equation balanced, that means we also have to put a 2 on the left side of the equation. So once we multiply this out, we see that the force increases to 100 newtons. And this makes sense that the force increases, since heavier masses will have a greater attractive force between them. Let's do another question. The force between two objects is 50 newtons again. What will the force be if both objects double in mass? Now, this time we have this original equation again, okay? And if we double one mass, we have to put a 2 next to one of the masses, and that means we'll have to put a 2 next to the 50 to balance the equation, just like we did in the problem before. And then we have to double one of the other masses, which means we have to put another 2 on the left side to keep the equation balanced. So notice that there are 2 2's on the left and 2 2's on the right. The equation is balanced. So when we do 50 times 2 times 2, we see that this force is 200 newtons. And it makes sense, once again, that the force would increase since both of the masses increased. Now let's talk about the inverse square law. So we know that the force equation here is proportional to 1 over r squared, which means that the force varies inversely as a square of the separation. Since the separation distance isn't just simply proportional like the mass was, it isn't as clear to how manipulating the separation distance will change the force. This may seem confusing at first, but once we do a few problems, hopefully we'll gain some clarity. So let's look at this problem first. The force between two objects is 100 newtons. What will happen to the force if the distance between the two objects doubles? So we know that our original equation will look something like this, where the force is 100 newtons and we don't know any of the other variables. If we want to double the radius, we're going to put a 2 next to the r down here. And notice that the 2 is also going to be squared along with the r. So since we put a 2 squared in the denominator on the right-hand side, that means we also have to put a 2 squared in the denominator on the left-hand side. And dividing 100 by 4, we'll see that the force decreases to 25 newtons. So it makes sense that the force decreases because the objects are becoming further apart. Now, what will happen if the distance quadruples? So we have our original equation here, and we're going to put a 4 next to the r because that's when we mean quadruple. And since we have a 4 squared in the denominator on the right-hand side, that means we have to put a 4 squared in the denominator on the left-hand side. And we will find that this force decreases to 6.25 newtons. So take note that the further and further away the objects become, the weaker and weaker the gravitational force also becomes. Now let's tackle a slightly different problem. The force between two objects is F, so we just have a generic F now. What happens to the force if the distance between reduces by half? So once again, we're going to have our generic force equation, and we're going to decrease r by 1/2, so we're going to put a 1/2 next to the r. So since we put a 1/2 squared in the denominator on the right-hand side, we have to put a 1/2 squared in the denominator on the left-hand side like this. And whenever we divide by a fraction, it is really just like multiplying by the denominator's denominator. So this is going to simplify to f over 1/4 once we put through the squared. And then when we divide by a fraction, it really just flips whatever in the denominator of the denominator. So we get a value of 4f. So this also makes sense because the closer two objects are, the greater their gravitational force will be. So let's do one quick last problem. So we want to see what the force will be if the object separation reduces to 1/3 of its original value. So we have our original equation here, We are reducing r by 1/3, so we must put a 1/3 squared in the denominator of the left-hand side. And then once we put out all of this math and compute all of this, we see that the force is now 9F.